Good morning, students. Today's topic is the deviation from the Rawls law, and this is all about the non-ideal solutions. So, if the two components consider A and B of the mixture of the two volatile liquids differ in the physical and the chemical natures, the solution form is the non-ideal such, and such solutions do not obey the Rawls law. So, if we are taking the two reactant materials, two components that is named as the A and the B. If they two are the volatile liquids but they are differ in the physical and the chemical properties, means not in the same natures, at that time the solution forms it's a non-ideal solutions, and just non-ideal solution do not obey the Rawls law. This is today's topics. So the friends, in the last lecture we have studied the concept that is the P. That is the P means the pressure of the partial vapor pressure of the components. If the P dash A means the partial vapor pressure of the pure A, and XA concept we have used in the last lecture, that XA means the mole fraction of the that particular component A, and XB is the mole fraction of that particular component B. So next point is the solutions showing the positive deviation from the Rawls law. So solution showing the deviation from the Rawls law, which solution show the non-ideal solution shows the positive deviation from the Rawls law, and the solution showing the negative deviation from the Rawls law. And in case we are studying the two cases here, one is the one case the positive deviation, one case the negative deviation. The solution showing the positive deviation from the Rawls law, it is the first point we have to study. If the force of the attraction between A and B, if force of attraction between A and B molecules are weaker than those between the like molecules A and B oblique B and B, that is the solution shows the positive deviation from the Rawls law in this case. So in this case, when the force of attraction between the two compounds starting materials A and B molecules, which is should be unlike, are weaker than those likes molecules A and B are in B, the solution shows the positive deviation from the Rawls law. So in this case, vapor pressures curves of the constituents and the mixture rise above to those of the ideal solutions by lines. So here is the mentions XA mole fraction A, XB mole fraction B. When the XB is equal to 1, at that time XA is equal to 0. When XA is equal to 1, at that time XB is equal to 0. Means the one component absent, one component present. So in this case, when XB is equal to 1, is and at that time the partial pressure of the vapor pure component B is 100%, and when the XB is equal to 0, then the partial pressure of pure component A is 100%, and the total vapor pressure curve is given by T is equal to constants, mole fraction value and vapor pressure is also given in the diagrams. So it is represented by the total vapor pressure is also decreases. Total vapor pressure is also decreases. So the positive deviation arises from the fact that the tendency of the molecules of the each kind to escape from the solutions to vapor is greater in the ideal solutions in case of non-ideal solution and that ideal solutions. So when the positive deviations arises from the fact that the tendency of the molecules of the each kinds to escape from the solutions to vapor is greater in the non-ideal solutions than in the ideal solutions. So it depends on the further on the such as the factors such as the difference in the polarity of the molecules, differences in the length of hydrocarbons chain of the molecules, difference in the intermolecular forces of the attractions, and the association of the either of the constituents in the liquid state. Example: carbon tetrachloride CCl4, heptanes, ethyl ether and acetones, heptane and ethyl alcohols. The solution showing the negative deviation. If the force of the attraction between the unlike molecules A and B are stronger than those both like molecules A and A or B and B, the solution shows the negative deviation from the Rolle's law. Second condition is most important. If the forces of attraction between the unlike molecules are stronger, first case is the weaker. The second case is the stronger than those both like molecules A and B and B. The solution shows the negative deviation from the Rolle's law. In this case, vapor pressure curve of the constituent and the mixture lie between the ideal lines. So here is the positive deviations is given here. He is also mentioned the factors along the one axis is the mole fraction, another another axis is the vapor pressures. Mole fractions sides when the mole fraction A is equal to 1, then the mole fraction B is absent. When the mole fraction A is equal to B is equal to 1, at that time mole fraction A is absent. So when the mole fraction A is present, at that time partial vapor pressure of the pure B is indicated here, and when the mole fraction A is present, at that time partial pressure of pure A is mentioned here because another factor is absent. So we draw this and we get the curve that is the positive deviations, and this deviations positive means that it is increasing or above the graphs when it is stronger, when the forces of attractions are the stronger. So at that time we indicate the hyperlines, and it is indicated by the negative deviations. So the tendency of the negative deviation arises from the fact that the tendency of the molecule of the each kind to escape from the solution into the vapor of the row as related to the ideal solutions. So in this case, we have studied that the tendency of the negative deviation arises from the fact, and which fact? The tendency of the molecule of each kind to escape from the solutions. Okay, because he's having the stronger force of attractions. He having the stronger forces of attraction between unlike molecules are stronger than those the both like molecules. So in that case, tendency of the negative deviations arises from the fact that the tendency of the molecules of the each kind to escape from the solution into vapor is the rho as related to the ideal solution is low as related to the ideal solution, because the force of attraction is more to bonds become solutions. More attractions means it cannot be easily escape from the solutions, so that there are low tendencies, so vapors to low tendency of the vapors to escape from the solutions related to the ideal ones. So this is all about the negative deviations. So next parameter is the, it depends on the which factors. Okay, so there are some factors on which it is depends. So we will discuss all these factors so that we can understand the negative deviations very well. So it depends on the interaction between the unlike molecules, because the interaction is why it is required, because we are taking the molecule which having the more force of the attractions, so it is deals with the interaction between the unlike molecules. The deviation is large if the two constituent from the partial compounds, two solutions constitute from the partial compounds in the solution. In such a case, minimum total vapor pressure is observed. So examples are also given here. The one example is the pyridine, and another example is the formic acid. Pyridine and the formic acid, these are the two examples having the more force of attractions and give the negative deviations. Another one example is the chloroform CSCl3 and the acetone, both are the organic compounds and both having the more force of the attractions, and it gives the negative deviations also. Next one is the halo acids and the nitric acids. Halo acid and nitric acids having the more force of the attractions. Both are the volatile compounds, but due to the more force of attractions, they cannot escape easily and having the more and more negative deviations in this case. So the next point for discussion is the distillation of the solutions. So we understand these points very well. Next point is distillation of the solutions. So in case of distillations we know that distillations is the temperature criteria. It depends upon the temperatures, and for distillations it depends on the melting points or boiling points also. If there are liquids, boiling points is the main key for the distillations. But again one condition that the if you are taking two liquids, both liquids are volatile but having the big difference in their boiling points, at that times we can easily distill out one, and then the and it as it is reaches to its boiling points. But if there is a less and slightly difference in their boiling points, so we cannot separate these two solutions, these volatile solutions, by distillation method. So this is the distillation method's limitations also. So where we use distillation only in case when there is some amounts of the difference in their boiling points, and some that difference, by this difference we can separate it out. So distillation method is most important. In the TY study, TY chemistry, organic chemistry, we provide you the these types of two volatiles or non-volatiles, liquid and solid compounds mixtures to identifications. At that time we provide you the complete set of the separating complete set of the distillations, and these distillations we in each practicals we perform and we separate by using the heating used distillations. Because in case of the if there is a only solid liquid, so you can easily separate, but if there are both the volatile liquids at that time, it will require the specific equipment, that is distillations of the solutions. So it is the most important topic as we study it in the organic chemistry or separation chemistry or analytical chemistry. So distillation of the liquid mixtures is the carried out to separate the one component from the other ones on the basis of their difference in the total pressure at the constant pressures of one. So pressure is required because having the pressures, volatile compounds having the some pressure. Definition of the boiling points. The boiling points is the of a liquids mixtures is the temperatures at which the total vapor pressure becomes equal to the external atmospheric pressures. So the variation of the boiling points with the compositions depends on the types of the liquid mixtures. So there are three types of the liquid mixtures. These three types, the variation of the boiling point with composition depend on the types of the liquid mixtures. There are three types of the liquid mixtures. Type first, the liquid mixture from is the ideal. The variation of boiling point is regular with the compositions. Type first is the if the liquid mixture forms is ideal, the variation of the boiling point is regular with the compositions. The boiling point of mixture is intermediate between the boiling point of your components. So example is the for this is the mixture of the methanols and the ethanols. So if the liquid mixture form is the ideal and the variation of the boiling point is regular with the compositions, the boiling point of the mixture is intermediate between the boiling point of your components. The example is the mixture of methanol and ethanol. Type second is the If the liquid mixture shows the negative deviations from the Raoult's law, then the boiling point curve shows a minimum at on intermediate compositions, example ethanol and the water systems. And type third was if the liquid mixture shows the negative deviation from the Raoult's law, if the liquid mixture shows the negative deviation from the Raoult's law, the boiling point curve shows the maximum at the intermediate compositions. Example is the water and SCl. So this is all about today's points. We have covered a lot of points. Today's we have covered the Raoult's law, and we have covered the mm, negative deviation and positive deviations. Along with we have covered the types and boiling points. All these points we have covered. So we'll meet in the next lectures along with the new topics. So the friends, we thank you and thank you very much.